Hi, this is Damiano from AstraKode, and in today's video I'm going to introduce you to AstraKode Blockchain, an innovative platform for blockchain development. So, let's get started. As a first step, we are going to create a network project based on the Hyperledger Fabric technology. This is a permissioned blockchain technology very suitable for enterprises. The AstraKode Blockchain Platform provides an environment dedicated to network development. In the next minute or so, I will show you how with this environment you can create a custom blockchain network in just a few steps. To start, we define the organizations that are part of the network. For this sample network, we're going to create 3 organizations, 2 clients and 1 orderer. After creating the organizations, we make sure to include the 2 client organizations in a consortium so that they can transact with one another in the same channel. As you can see, the platform assists you throughout this whole process by providing default configurations for each component. In the meanwhile, in the visual development canvas, our network topology is shaping up. After making sure that each of the client organizations has a peer available to transact, we also increase the redundancy of the ordering service by defining a few extra nodes. After making sure that there are no outstanding issues present, it is now time to generate. After selecting the right operative system where our network will be running, we can complete the process and download the necessary artifacts for the network to be spun up. The outcome is the folder you can see in the screen. The BC network style directory contains the script that is necessary for the network spin up. It is enough to invoke the network with the app argument to start a process that will deploy all the network artifacts as well as perform an end-to-end testing by installing a custom chain code for this purpose. Finally, we can see that all network elements as Docker containers are now present and running on the machine. Next to a Hyperledger Fabric network, the platform also allows you to create custom smart contracts through a dedicated visual environment called the Smart Contract IDE. For the purpose of this video, I'm going to create a contract centered on document notarization. Since this is a Hyperledger Fabric contract, the first thing we will need to take care of is to define the asset that will hold the information for the document. To do so, we are going to define all of the properties that we want to store for each document to be notarized. Each property can be defined according to a simple or a more complex type. In our case, all of our properties will be strings. For the document asset, we want to store the ID, the title, the owner, and the metadata. The document's ID will also serve us as index for our queries on the ledger. Once we have defined our asset, it is now time to define functions for the asset to be inserted and queried. With respect to the first function, we define the input that is gonna need to provide all the properties necessary for the insert. In this case, we are basically mapping the properties that we defined for the document asset as a whole. Once defined the function, it is now time to leverage the visual editor to design the function's flow and thus model its underlying logic. The core of the logic for this function is the definition of a ledger transaction of type insert, where we take the function's input and map it to the expected asset structure. Once this is done, we also decide that we want to return the inserted document by leveraging the dedicated component. It is possible to notice how throughout this process, the platform assists you by providing default configurations as well as type coercion and other means of validation. Finally, we're now going to define a function to fetch documents from the ledger. Contrary to the previous function, this time we only need to define the ID as input, as that will be the value for which we will query documents on the ledger. Again, the central part of this function's logic will be a ledger transaction, but this time centered on the querying of the document. Naturally, we are also going to return the query result as a return for the function, so that when invoking the function, the return of the function will be the actual query result. Once these 2 functions are defined, our modeling process is done and we can proceed with generating the project. The outcome of the generation will be the code for the contract that we just modeled in the platform. As you can see from the screen, this code is not particularly complex, but it is in line with what was modeled in the platform. Of course, more complex use cases will result in a more complex code that the platform will anyways be able to handle due to the array of components available for modeling. Thank you very much for the attention, and don't forget to come check us out at astrakode.tech.